Hi everybody, I'm Mary Purvis from CVTC Science Department. You know, in the old days, buying light bulbs was pretty easy. Nowadays, if you look at a light bulb, you got choices. And there's warm light bulbs, there's cool light bulbs, and somewhere on the side of the light bulbs, there's a little tiny number that says something like 5,000K, and this one says 2,700K. What does that mean? Well, here's what it means. That K stands for Kelvin, and Kelvin is the Kelvin temperature scale. 0 Kelvin is absolute zero. That's the coldest temperature that exists. So what does temperature have to do with light bulbs? If that 5,000 Kelvin that's on a light bulb, well, that would be 5,000 Kelvin, that's the temperature of the surface of the sun. Your light bulbs are not going to get as hot as the surface of the sun. So what does that mean? Well, in 1900, there was a German scientist, Max Planck. And Max Planck was doing some work with objects that change color when they get hot. So if you examine something like a horseshoe, when they start out, they get red hot. And then the hotter they get orange hot, yellow hot, white hot, and then eventually blue hot. Well, due to the work of Max Planck and his colleagues, they developed things that were called black body radiation curves. That if you get an object that gets really hot, they have a peak temperature, the hottest temperature they get, and the dominant color corresponds to the color of the object and the temperature of the object. So on my light bulb that says 5,000 Kelvin that you have down at your hardware store, what that means is that light bulb that says 5,000 Kelvin corresponds to something that gets blue hot. And that means that that light bulb is going to be closer to the blue end of the visible spectrum. It's going to give you all the colors of the rainbow if you use this light bulb. Now, if you use another light bulb that's maybe 2,700 Kelvin, what that means is, again, you're going to have all the colors of the rainbow, but the peak color, the dominant color, it's going to be shifted down here, so it's more in the red range. So if you want something that's more romantic candlelight, go for the 2700s. If you want something that's more like daylight, because 5,000 Kelvin is the color of our sun, then that's the light bulb you need to buy. So this is how a German scientist from over 100 years ago, a little bit of quantum mechanics can help you buy light bulbs. If you want to find out some more about science in general or classes that you can take here at CVTC, please go to cvtc.edu.